So that's a simple one. But if you take that same car and put it in your garage, now you've got all the stuff in your garage. You've got the structure, you've got the attic space, you've got the interior, you've got a lot more going on. So here they're showing us kind of a worst case scenario. We have a fire here. And so we can talk about the victims, but right now we are going to consider them, well, they're not really in a safe haven because that little cartoon has got some smoke. So we need to get those people out. It looks like we're looking at windows here, so they can come out the windows. If they're not windows that can be taken out from the inside, like that have openings and stuff like that, we can tell them to stand back, motion for them to stand back, and then we can take out that window and bring them out that way if we need to, unless we can get them out through here, this main exit, or if there's a rear. That's fine. The exposure. The rooms around and up above, because fire wants to go upward and outward, okay? Think of a V. That's what fire wants to do. So it's going to want to head out into the hallway from this room, and it's going to want to go up. So that's why it's got like a bigger cartoon picture over here, I guess, because smoke wants to go that way. So that's going to be something we're going to look at. Now, some buildings do a better job of blocking fire from doing that. So if you stay at a hotel, then you've probably got a pretty good blocking system, and a nicer, newer, modern hotel. Don't go for the old, open staircase one. Nice modern hotel. Then it's going to be blocked. Actually, every room should have concrete that you're standing on, concrete above you, and concrete on all your walls, then a steel door or steel frame, and then whatever the door, depends on what rating they want, whether it's wood or metal. All right, so fire here, exposure, radiation. So radiation moves in rays or waves in all directions from the source. So even though it only shows it going right, it also goes up, it also goes left, it also goes down, but that pretty much gets absorbed by the floor or the ground. All right, but then we've got convection working in here, okay? And the wind, obviously, is kind of blowing in that direction. So that becomes a problem for these upper floors, particularly if they have windows that open. If they don't, it's going to hit the windows and go up just like everything else. The fog and the mist and the rain and all that other stuff. It's not going to be a problem. But if there are openings, then that smoke can work its way in there, and can embers, as you have seen from campfires and things like that. So what's in that building? If it's a vacant building and it's concrete floors and machinery, then it might not be too much of a hazard. But if it's apartments, and it's got carpeting, and it's got drapes, and it's got blinds, and it's got shears, and it's got all those little things that are very flammable. So we have to think about going over here and checking for extension into the exposures. All right, so it might be the first slide we saw on exposure. So did I tell you about my first major fire where I had to protect an exposure? All right. Young me, at home, get a call for a reported structure fire. So, oh, this is good, this is good. So hop in my Volkswagen Rabbit, and I'm driving to the fire station. I got that great big old bubble on the top of my car, which is about a third the size of my car. And I'm going down the road, and this is cool, this is it, it's got fire, it's a fire. And we've had several calls from neighbors that this is a confirmed fire. Yes, 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 yes. And then I pull into the station, and a bunch of people are getting out of vehicles, and we're all running and grabbing our gear and hopping on the truck. And police officer on the scene confirms that it's a working structure fire. Yes, 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 yes. So we get there and hop off the truck, and there we are, this nice roaring house fire. Probably a quarter to a third involved, so I'm thinking, yes, this is it. This is my first real major one. I'm going in. Kursky, yes, sir. See that line over there? Yes. Small little red line, booster line, yes. See that garage over there? Yeah, fire over there, garage over there. Yeah, I see it. Make sure it doesn't catch fire, use that line. What? Okay. So, it was an exposure. It was close, it was radiant heat, it was a freestanding garage. So I had my little booster line, spraying it with water and wishing I was in here, watching everyone else come out and they're having a good time and all this stuff going on. And I'm spraying water, it's getting muddy, shut the line off. And then it's like, well, you know what if it catches fire, and here's this dummy is sitting, one job in the whole world, make sure that doesn't catch fire, and it caught fire, so how much water should I be using? I don't know. So keep going with the water, and eventually they said, you can shut that off once the fire gets knocked down and stuff like that. So that was my big, exciting first fire that I didn't get to go in and do anything on. So I was on exposure protection. Non-glamorous, not glorious, didn't get to go home and tell my family, hey, I got to go protect the garage. Oh, how bad was it? It wasn't burning at all. Oh, okay. Like ours. Right, kind of like ours. Okay, but you made sure it didn't burn. Yeah, like ours. Yeah, kind of like ours. Okay, good. Make sure ours doesn't burn. Okay, fine. So, exposures. You got to do it. Depends on the proximity. Depends on the wind direction. Depends on all those other things. Who told us yesterday, who remembered the 3 methods of heat transfer? Past week, whatever.
Conduction, convection, and radiation.
All right, which one don't we see here?
Conduction.
All right, why not?
Because it's not 2 objects touching each other.
Because there's not direct physical contact between anything here going from one to the other. Okay, so conduction is by physical contact, like a wire hanger, like the ductwork, like the conduits, any of those types of things. Good. All right, ventilation location. Gather as much information as possible about the fire, the building, and the occupancy before ventilating. So again, this book talks a little bit about, we covered the firefighter 1, the firefighter 2 stuff. Difference, almost no one goes into this to be a firefighter 1. Almost everyone's going to be a firefighter 2, but we can stop at fire 1. Again, situation, old retired police officer or sheriff who always wanted to be a firefighter, we're their heroes. And then after they retire, they go through and they become firefighter 1. They don't want to go interior or anything like that. They just kind of want to maybe help out from the outside. Okay, go fire 1. All right, so firefighter 1, they can do much less than a firefighter 2, as you know. Firefighter 1 will be instructed where to ventilate and responsible for communicating observations about performing ventilation. So really, when you look at the book, the firefighter 1 can do almost everything that a firefighter 2 can do. Yeah, 2/3 of what a firefighter 2 can do. They just typically don't. If they stop at fire 1, there's usually a reason, because in the state, fire 2 is pretty much what all the firefighters have to be. So if someone stops at fire 1, there's usually a reason. Like, hey, I'm old, and I don't want to go into a burning building anymore, or my knees are messed up, or because of surgery. But there's other things I can do to help out. I can throw that ladder for the roof team. I can fill cylinders. I can hook up to a hydrant. So there's room for firefighter 1s, but no full-time department is going to hire anyone with just firefighter 1, because we expect firefighter 2, that's what the academy is, and so that's what we're going to hire. But out here, you could also be firefighter 1 too. A guy who I worked with in Dearborn Heights, worked for Howell, I don't know if he's still there anymore, but he drove the truck and pumped the truck. Never went inside, never put the gear on, never did any of that stuff. So he kind of operated like a firefighter 1. Roof integrity. So prior knowledge of the roof's construction and building layout can help you gauge the roof integrity. So again, you're just going to have to get up on some roofs and feel what they normally feel like, and then you'll figure out what they feel like when they are not quite so structurally sound, and communicate that if you do. Are you going to go through roofs on pre-incident planning? Not residential, typically. Sometimes commercial, they'll have an interior access, and we'll all go up to the roof and see stuff there, because that's typically in your commercial buildings. That's where your HVAC units are. So we do have to get access for those, because sometimes there's some problems with those units. All of us, we go into our house, into the basement, or into the back storage room, or mudroom, or entrance, or breezeway, or whatever you happen to call that. But for buildings, commercial buildings, it's usually the roof. Structural elements that may contribute to a roof failure during a fire, well, lightweight wood trusses, so the less material, the more likely. Open floor plans under wide expanses with limited truss supports. So what that means is this. It's exposed to the fire, as opposed to there's a drywall layer below it, which keeps the heat from getting to the structural elements. And then prior structural damage, so previous problems, alterations, age, deterioration, etc. All right, so some model building codes require placarding or signage on structures to indicate the presence of lightweight construction, most notably floor and roof systems. So, building codes. Building codes are the documents that tell a builder how to build a building. Okay, well, I was actually just thinking about running a small little gauge wire to one outlet inside of my home. Codes don't allow that because we know we're going to have a lot of stuff to plug in homes, and a thin gauge wire is not going to cut it. So there's minimums of what you have to have. And that's what the model building codes do, is they tell you what you have to do to build a home or other building. So some require placarding or signage, usually on the alpha side of the structure, that indicate the presence of firefighter hazards. So lightweight construction would be done, lightweight floor or roof systems, that would be placarded on the front of the building. Do you think that the building people want hazard signs on their building? No. You think they have a legal department that's going to try to fight it? Yep. So you're almost never going to see that. The thought is there, but you rarely will you ever see it. I mean, you might, I'm sure you can find a picture somewhere online. If you look, you'll find it. But in real life, I don't think you're going to find it. If you do, take a picture. Roof integrity. If the roof is suspected or known to be unstable, okay, you've been there before, it's a vacant building, it's falling down, okay, the IC should not place personnel on or under it. Okay? If ventilation is ordered, check the roof before stepping onto it and continue checking across it. Take that tool, give it a couple good whacks. If it seems structurally sound, gingerly that first step, okay, and then go from there. If the fire has vented through the roof or has burned under it, ventilation should not be considered until the fire has been suppressed and the roof structure can be evaluated. But the bigger picture is if the fire has vented through the roof, isn't our job pretty much done? That's what we wanted to do, right? Get a hole in the roof? The fire took care of it from the other side instead of us from this side. So, yep, ventilation is complete. The fire has burned a hole through the roof system. Engine 1's coming down. Indications of possible roof collapse. So there's one. Nothing there. Melting asphalt. So that's going to be commercial. Smoke or fire coming from the roof. You can see all of that here. Sagging or leaning building systems. So they kind of sag between these structural supports. A spongy roof. So that's why I said step gingerly initially, because if it starts to give under your weight, it's certainly not going to hold your whole crew up, or you have to be suspect anyway. We don't want to take that chance. Some roofs are spongy with no fire involvement. Know the roof types in your response area. So there are some commercial buildings that will have a sound deadening up above this corrugated metal roof. So have we been here when it's rained really hard?
Yeah.
Did you hear the rain hitting the metal? Or no?
Yes.
Oh, yes.
Okay, so then this may not have a lot of insulation, but some structures will put a foam insulation above this, and then they'll put that rubber membrane roof on that. So you've got foam and you've got membrane, so when you step on it, it will be spongy. That's by design. So you'll get to know that with age. Roof integrity. Ventilation teams should communicate with other crews. Roof loses integrity during roof ventilation. Let people know, because part of the roof could be coming down. And evacuate the roof and notify command that you're coming down because the roof feels spongy. Don't feel safe. Yep. What is this one? You're assigned to perform ventilation at a 2-story commercial building. What conditions should you look for and be prepared to communicate to your supervisor or teammates as you ventilate? All right, so those. All right. Questions? All right. Ventilation tools and equipment. So what do we need to do it? To perform ventilation, we're going to create openings where gases and smoke will exit the structure. Duh, that's kind of what ventilation is, right? The planned and systematic removal of heat, smoke, and toxic fire gases from the structure with planned coordinated tactical ventilation. Assist in moving gases and smoke more efficiently. Help access ventilation locations. Monitor ventilation and identify ventilation locations, the things that you can be used that would be helpful. Skylights, someone mentioned. Tools for creating opens, an axe, all right, so very old school, but always a plan B. Chainsaw is going to be your tool of choice for residential, where you've got to cut through asphalt shingles and plywood. A rotary saw is going to be your tool of choice for flat roofs on commercial buildings. A pike pole to break through the ceiling underneath it. I believe your book talks about a charged hose line, a radio, thermal imager may make its way up there as well. Ladder, you can see the roof ladders on the residential. And over here as well. So nice, he's got 3 to 5 rungs over here on the extension ladder, then he's got his roof ladder that he's working on here. All right, air movement equipment, air movement devices. So fans and smoke ejectors will get wind. Hose line and nozzles, what's on your vehicle. Flexible ducts, so that's going to be for that PPV ventilation where you put, or PPA, where you put the fan in front of the structure and you start it up. Again, it's a gas engine, internal combustion. It's got CO, so that flexible duct is going to move it off to the side. Stacking and hanging devices, you may have to hang a smoke ejector from a doorway. So S hooks or J hooks, something like that, or a bar that you can extend. Generators or electrical cords, because the smoke ejector runs on electricity. Wind control devices, kind of new. You don't see them a lot out there, but ever see a movie where the one person, usually it's the female, the man sitting here, and then the female goes behind a screen and it takes her whatever off and puts whatever on, let me change, and that kind of thing, just the screen?
Oh, yeah.
Okay, so that kind of movable partitioning screen thing. They're out there, not too many people get them, but that's meant to be a wind blocking device for fire purposes. Easy, quick to set up, like a shade-ish of sorts, like a movie screen. Okay, you got the little tripod here, and then you extend it out and hang it. That. So we're playing with those. I don't even think we have one of those. I can show you, I will at some point, our piercing nozzle, our cellar nozzle. We do not yet have a wind control device that I can show you. And then smoke control devices, so I can show you some of that. All right, so here is some. This is your PPV fan. Positive pressure ventilation is what that stands for. There's your internal combustion engine here, a little gas tank over here, and then when you start it up, it is going through, move these fan blades. Smoke ejector. Smoke ejector is very old school. We have one because we still talk about it. I don't know if the 8th edition will, but the 7th edition does. This is on a hanger that's adjustable, so it's a rod that you can pull out. It's like the jack on your car, if you have those jack car things. Okay, this does the same thing here. You can get it close and then jack it up into place. It locks in between the door frame, and then you can hang your smoke ejector from it with S-hooks. Hose line and nozzle for hydraulic ventilation. And then generator and cords if you are using this. This runs on electricity, the smoke ejector. The PPV fan does not, internal combustion engine. Tell your hand up.
Why are the smoke ejectors going out of use?
Good question. So smoke ejectors were like, who's got a window fan at home? Okay, so you know what those are. That was about as good as that was. A little bit more beefy, a little more heavy duty, less plastic, more metal. But these, and you don't have to write this down, but just to let you know, These will move about 5,400 CFM, cubic feet per minute. Okay, just a number that we use to test fans out. See how much air they move. 5,400. 40,000.